All right, so now we're into applications of exponential and logarithmic functions. And the most common application for an exponential function is talking about how a population grows. So generally we use this formula. So it's a function of time. So P of time is our population. So our new population is equal to the initial population. So P sub 0 is the initial population, because if I plug in 0, let's look at that. P of 0 is P sub 0 times a to the 0. K times 0, of course, is just 0. So we get P sub 0. So we call that our initial population. And our a value here is going to be our exponential base. So if we're doubling, it's going to be 2. Tripling, it's going to be 3. And we bring in this growth decay constant, and it goes with the t. So we know anything that's up with the variable affects it in the opposite way. And we call it our growth decay constant. It usually has to do with how often something happens. So let's look at this example. We've got a group of 100 bacteria, and it doubles every 3 minutes. So starting just with a table, we start with 100. So time is 0, we get 100. After 3 minutes, we double. And then we double every 3 minutes. 1,600, 3,200. So I can see that it's doubling, and normally I would think that my equation would be that my new population is my initial times 2 to the time. But this would mean if I plugged in 1, after 1 minute I would double, and that's not true. It's after 3 minutes I double. So let's plug in this point so that we can find our k value. So we need our k up there. So I could pick any point. Let's go with 9. So after 9 minutes, I have 800 of my bacteria. 100 times 2 to the k, and then my time is 9. So divide by 100, and I get 8 equals 2 to the 9k. Well, I know that 8 is 2 to the third, so 9k equals 3, and k is 1/3. So think about my equation now. If I have my equation, a equals 100 times 2 to the 1/3 t, well, this means that after 3 minutes, when I plug in 3, my exponent turns into 1, because 1/3 of 3 is 1, so that means I've doubled after 3 minutes. So here's my equation. Estimate the population at t equals 10. Well, a equals 100 times 2 to the 1/3 of 10. So a is 100 times 2 to the 10 over 3. Using my calculator, 100 times 2 to the 10/3. And I get that my population is about 1,008, but I don't say 1,008 because I haven't actually hit the 1,008 yet. So my population is about 1,007. So about 1,007 bacteria. Because as of 10 minutes, I haven't actually hit 1,008 yet. It has to be more than 10 minutes to give me 1,008.